specialized counting studies where we are trying to find out the entry and exit of traffic in a particular area. Okay. So we discussed origin destination studies yesterday. Okay, which can be done with different methods. Whatever method you apply, you will get a matrix like this, and you have to adjust the matrix to get the actual count, because the method of origin destination count gives you a sample. Okay, so we discussed how to adjust the matrix. Today we will move on to another specialized counting study, which is the cordon count. Okay, cordon means a boundary. Okay, so the cordon of this class is this wall. Okay, the wall is the cordon of the class. Okay, anything which surrounds you. Okay, anything which is around you is called a cordon. Okay, so in cordon count we select an area, which should be a very important area. Okay, normally it is a commercial area. Okay, a very busy commercial area. The technical term for that type of area is CBD. Okay, CBD, not ABCD. Okay, CBD, Central Business District. Central Business District. Okay, so normally cordon counts are done for CBD areas. Clear? Okay, so now you have to do two. Your extra one. No, you can do one. Okay. What is the purpose of cordon count? We want to know how many vehicles at a time are inside the area. Total number of vehicles which are inside the area at a particular time. This is the aim of doing cordon counts. Okay. Now the vehicles which are inside the area, any vehicle which came in and didn't go out is inside the area, right? Any vehicle which came in and didn't go out is inside the area. Okay, so we have to find out how many vehicles came in and how many vehicles went out. Whatever the difference is inside the area. Clear? Okay. Now the cordon is an imaginary boundary. Okay, the cordon is the imaginary boundary. We don't actually have a wall or a barrier around the area. You only have a map. Okay, so in the map you mark, okay, this would be my cordon. Okay, you have to mark it. Okay, so since you are doing it, so there are some guidelines you have to keep in mind. Okay, first thing is the size of the area. How much area should be inside the cordon? If you select an area which is too big, okay, then the activities inside the area will not be all commercial. Okay, now give me an example of a commercial area in Bahrain. Tell me. Any commercial area in Bahrain? Isa town. See, right? And what in front of Isa town we have Lec4.6, right? Which is not so commercial. So if you make the boundary too big, you will include Lec4.6 as well. So now you see, you have a commercial area and a residential area in the same boundary. This will not give you accurate data because there are too many things happening inside the area. Okay, so you have to keep the boundary so that you have only one activity inside the area. Okay, but you also have to make sure that any facility which is related to this area is inside it. Okay, like in Isa town, which we have the market area, right? Okay, we have the main market, the Isa town market, right?
Sultan Mall.
Sultan Mall. Okay, the Sultan Mall is on the other side, right? It's not part of it. Okay, somebody says, okay, I will just focus on the market area. I will not include the entire Isa town. This is also wrong. Okay, because you said the entire area is commercial, right? So now in the area you cannot select one particular point. Okay, clear? So you have to make sure the boundary does not include many activities, and whatever activity you are selecting, it should include all of it. So it should not be big enough to have many activities, and should not be small enough to leave out anything which is related to your activity. Okay, you have the big market, but then you have the small malls and stores and these things as well. Okay, so you have to group them. Okay, so boundary should be selected properly. When you are making the boundary, make sure the boundary crosses at the midpoint of the road. Okay, so for example, I am making my boundary. Okay, and there is a road going like this. Okay, and here I have the intersection. Okay, so there is an intersection. Now I have the choice. I can make my boundary go like this, cross like this, or I can make it cross like this. Okay, few meters here and there will not change the area so much. Okay, but which one is easier to count? This thing or this thing? This one, right? Because this will have many directions. Okay, so we make the boundaries on the road itself, not on the intersection. Clear? In some cases, I told you the boundary is imaginary. We are making it. In some cases, the area is in a position where you find an existing boundary. Okay, where you find an existing boundary. Okay, for example, okay, we have, like, for example, sea on one side. Okay, there's sea or beach on one side. Okay, or a shoreline. They call it the shoreline. Okay, so this becomes a boundary, right? You don't have to think, oh, okay, where should I make the boundary? This is the boundary. This is where the area is ending. Okay, the shoreline is one example which applies to us. Okay, but in other countries it could be a river, or it could be a mountain area. Okay, so that area or that line automatically becomes a boundary. This is the end of the area. Clear or not? Okay, so wherever you find these features which act as a boundary, you will make your boundary around them or with them. Okay, so for example, my boundary goes like this, and here I have the sea line. Okay, so naturally my boundary will be with the sea line. You don't have to think where should I put my boundary. The sea line is the boundary. Clear? Okay. Any questions? Okay. How do we do the cordon count? First of all, the timing is very important. You have to start the count where the activities are not started. So you see, in all the aspects, we are focusing on the activity. We want the traffic demand because of this act. Now you cannot leave. Now you cannot leave. You have to say. Go, 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 go. Okay. So the activity is very important. We are focusing on one activity. Which is what? Which type of activity? What type of area we are doing? Commercial. Okay, so normally commercial activities. Anyways. So you have to start when the commercial activities have not started yet, before the opening of the banks and the malls and everything. Okay, so you start there. What is your first count? Your first count is inside the area. So you take a count inside the area. How many vehicles are parked? How many vehicles are moving on the roads? Inside the area. You did not go to the boundary yet. You are doing it inside the area. This is your first count. Okay, so when you started your survey, now you know how many vehicles are in the area. Okay, this is your first value, the first value in the table. You can see here, no counting, right? Nothing in the second and the third table. Only, sorry, nothing in the second and third column. Only, we have a count, 250. Okay, we did not say how many vehicles came in and went out. There's nothing like this. Okay, 250 is a count which we saw inside the area. That's it. Okay, once you have this 250, the first count, now you will go to the boundaries. Now what are you counting? How many vehicles entering and how many vehicles leaving? And what did I tell? What did I tell you? We are just taking the difference. Whoever entered or was in the area and did not leave is part of my count now. Okay. So 250 were already there. 100 more entered. Okay. Out of all that, 20 left. So how many vehicles I have inside the area? 330. Okay. Again, the technical term for vehicles inside the area is accumulation. vehicles which are still inside the area. Simple. Okay. So next one, how did I get 450, 440? 330 already there. Plus this minus those will be. Clear? So you will have the accumulation count. You can see it increases with the activity. With the start of the activity, it increases. Okay. When it comes to the evening, then it starts to decrease. Okay. This is almost ideal. You see, this is 270, and how much was the starting? This is almost ideal. Okay. We went back to the initial point. This is almost ideal, but obviously it may happen, it may not happen. We have a time period. After that time period, we will finish. Clear? The end count can be 300, 350, 450, whatever. We don't mind. This is one end of the activities. Clear? Okay. What do we do with these counts? So maximum number, how much is it? Accumulation. How much is maximum accumulation?
1,400.
1,400?
No, 1,180.
1,180. Okay. So at a particular time, I can have almost 1,200 vehicles inside the area, right? Okay. These vehicles are inside the area. They need parking spaces, right? They need parking spaces. Okay. And they will also need the space on the road to move around. So the total capacity of the area should be this much. Total capacity of the area, parking and moving, should be this much. If they are not providing it, then we have a problem. This is how the commercial areas are designed. Okay. Nobody mentioned soup areas. Soup Manama, soup Mara. You see they are small areas. Okay. You cannot provide parking for each of the shops and each of the malls. Okay. So this is how the parkings for these areas are designed. You look at the total. This is the whole area. Total parking I'm expecting is this much. Okay. And you may provide one big parking area on this side, other big parking area there. It will meet the total demand. Okay. But it cannot provide you at each point. Clear? Okay. This is the plot of accumulation with respect to time. So we know exactly at what time it becomes higher. Okay. So again, if you go to these soup areas, you will see the parking meters are with respect to time. After this time, they are free. At this time, the charge is this much and so on. This is the reason. Okay. When there is peak hour, the charges are there and normally higher. After the peak hour, it becomes lower, maybe free. Okay. So this is the reason here. In some cases, you may want to identify or you may want to focus on a specific type of vehicles. For example, you see they are focusing on trucks and automobiles means cars. So they separated the trucks and cars differently. Okay, they plotted two curves. Okay, because for trucks, I may have separate parking areas. Okay, normally they are separate, right? Trucks and cars are not in the same parking, even if they are going to the same mall. They have different parking zones, right? So this is where you can use it. This is a local study we did for diplomatic area. You see, it's a what do you call it? It's a commercial area, but not commercial with shops and malls. Commercial because of the offices and embassies and so on. Okay. This is a more detailed diagram of the cordon count. So in the earlier example, we were just looking at the total, right? Total entry, total leaving, total. But in this diagram, this is called a crossing representation. You can see from where they left. How many vehicles left from which point? And how many vehicles entered from which point? Okay. So some of the roads, so these are the roads. The solid lines are the roads. Some of them are one ways, like which one? This one. And this one, this one. So these are one way. You can only go in or come out. Okay. Some of them are two ways. Okay. So two ways and you see both counts. One way you only see one count. Yeah. Okay. So this is a more detailed representation and you can see the totals over here. Okay. But it is not just with respect to time. You don't know in which hour these many vehicles came. In the earlier table, you had the hours, right? This much vehicle, this hour. This much vehicle, this hour. We don't have the hours, but we know the exact crossing point. Okay. Then we have the screen line count. I mentioned yesterday, screen line count is like origin destination. A screen line count is like origin destination count. Okay, the same thing which we discussed yesterday. Okay, the difference is in origin destination count, I told you we divide our area into TAZs. TAZ means what? Anyone? Traffic analysis zones. Okay. So in an origin destination count, you can have any number of traffic analysis zones. You divide the area into 4 zones, 5 zones. The example which we looked at had 4 zones. But you can go up to 20 or 100 or whatever. Okay, there is no limit. Screen line count, you have a limit. The limit is 2. Okay, your area is divided into 2 zones. To divide into one area into 2 zones, how many lines I will make? I have an area. I have to divide it into 2. How many lines? 1 line. That line is called as screen line. Okay, the screen line is the line which is dividing your area into 2. Okay, right? And we have to keep the same points in mind which we discussed for cordon. What was the point? The first point was you make the cordon not here but here. The cordon should not cross from here but should cross from here. What is the difference between this and this? Why not here? More complicated because of the intersection. Okay, same thing here. You will make the screen line. Again, it is imaginary. You will make it on the map. When you are making it on the map, make it on the road, not on the intersection. Okay. And what was the second point? What was I showing here? Yeah, any line, not the C line. C line is applicable obviously. In our case, yeah, C line obviously. But any object which is going around the area, you make it a line. Okay, so in this case, any object which is in the area. Because you are not looking at outside the area, right? The screen line is between the area, right? You are dividing the area. So any object which is dividing your area. Okay? So you have, for example, Tubli and Sitra, so you have a C line between them. Okay? So this will become your screen line. It's already there, right? There's already a line which is dividing the 2 areas. So you don't have to think where is my screen line. This is your screen line. Got it? Okay. The procedure of doing screen line count is same as origin destination. The process of doing screen line count is same as origin destination. Okay? How do we do it? How do we adjust it? Everything what we have already discussed yesterday. The only difference is number of zones. Okay? This has how many zones? 2. And the other one, any number. Okay? So we are not going to discuss the procedure. I just want to show you this diagram, the graph. Okay? So the first map is showing the screen line basically. This is the screen line. And the arrows are showing the crossing points from where you can cross the screen line. Okay? So this is a representation. Once you have the count, you have done the count and everything. Okay, you have adjusted the table level. All the calculations are done. You will have 3 types of people, 3 types of travelers. Okay? Those travelers who are going from one zone to the other. They are inside the area. They are coming from one zone going to the other zone or vice versa. Okay? We call them internal crossing. They are part of the internal crossings. If you selected the area properly, the number of internal crossings should be higher than any other thing. Higher than the others. Okay? People who are going from one area to the other area should be higher than the other people. Okay? So if you have 1000 values, out of those 1000 values, these should be like 800, 900, something like this. Okay? If they are less and the others are more, then you have a problem. You did not select the area properly. You are doing the survey for an area where people are not going. You get my point? Okay? So, a screen line should be between 2 important areas where people have more demand. Okay? So, if this number is low, that means these areas have no demand or they have less demand than the other areas, then the study should be done for other areas, not for them. Okay, so internal crossing going from one zone to the other. Okay, the other people, who are the other people? They are just crossing, but they are not starting or ending their trip in these two zones. Somebody came from here, outside your zone. He crossed the screen line, but he is not from these two zones. Get up? Okay, so somebody started from here, he crossed, but he did not stop here. He crossed another zone as well, he was going somewhere else. Okay, so those trips are part of external crossing. So you can see external crossing is very low, and internal crossing is very high. And this should be the case. If you selected the area properly, this should be the case. Internal should be low, external should be high. Okay, and if you add both of them, we call them crossing. Okay, if you add internal and external, we call them crossing. Clear? Okay. Now let's say we want to do a count between Bahrain and Saudi. Now we cannot obviously do the whole Saudi. Let's say Bahrain and Khubal, right? This is the first city, right? We want to do a screen line count between Bahrain. Bahrain is one zone and Khubal is another zone. What is my screen line? The sea. Okay. So now you don't have to think where should I put my screen line on the map. You open the map, it's in front of you. Here is Bahrain, here is Khubal. Between you have the sea. Okay. So, okay. And what is the causeway? Yeah, I know the name. But what is it? The sea becomes screen line. The causeway becomes green line. You were saying? Bridge. It becomes bridge. It's always a bridge. It doesn't become anything. He said the C becomes, for screen line count, C becomes a screen line, right? And the bridge becomes the crossing point. Cross line, very good. Okay, the crossing point or the cross line. Okay, now there is no green line. Okay, so they do the screen line count, by the way. They do the screen line count on the causeway, and it's published every month or something like this. Okay, again some practice problems from both editions of the book. Have a look at them. Okay, now we come to the next topic, which is about capacity and level of service analysis. It is taken from 2 chapters of the book. Okay, and it's very important for your term projects as well as the final exam. So this topic is related to the outcome of the course, where you should know how to calculate the capacity and level of service for different types of facilities. Okay, we will start with the capacity and level of service for uninterrupted flow facilities. Okay, uninterrupted means what? No intersections. Okay, this is the ideal definition of uninterrupted flow facilities. Okay, so if a facility, a road, does not have intersection, we call it uninterrupted. There is no other way about it. Okay, but a road with an intersection can also be called uninterrupted in some cases. Okay, what is that case? When the intersections are more than 2 miles. Okay, so you have the first intersection, the next one is after or more than 2 miles. Then that road or that part of the road becomes also uninterrupted. Okay, so no intersection, we understand. But if the next one is after 2 miles, that still is uninterrupted. Okay, we will discuss 3 types of. So interruption means any of these things: signal, stop sign, yield sign, roundabout, all these things. We will discuss 3 types of highways here under uninterrupted flow facilities: freeways, multi-lane highways, and 2-lane highways. Okay, freeways are pure uninterrupted flow facilities, meaning they don't have intersections. Freeways don't have intersections. Okay, they only have ramps. Freeways only have ramps. Okay, so ramps are called as interchanges, not intersections. Okay, so freeways are those highways which have interchanges in the form of ramps. There are no intersections. So there is no way a freeway can be interrupted. There is no way a freeway can be interrupted. Okay, the other two, multi-lane highways and two-lane highways, they have intersections. So what is the difference between freeway and the other two? The intersections. Freeway doesn't have, other two have intersections. Okay. The other two, one is called multi-lane, the other one is called two-lane. So what is the difference between them now? Number of lanes. Okay. Both of them have intersections, but we are putting them under uninterrupted because their intersections are more than 2 months. More. Yeah. Clear? Okay. So this one without intersections. This one with intersections more than 2 miles and many lanes. This one with intersection more than 2 miles with only 2 lanes. Clear? Okay. The manual which gives us the procedure and definitions for capacity and level of service is highway capacity manual. Okay. This is a US based manual which is now adopted worldwide. Okay, and the first manual was published in 1950. The last one, according to my knowledge, is in 2022. And somebody told me that they are now doing it after every 6 years. So after 2022, it will be 2028. Okay, I hope by this time we will be graduating. Say inshallah. Okay. Who publishes this manual? This is the academy or the board which publishes the manual, and they publish other things as well. They have a journal, they have a conference, and so on and so forth. The calculations in the manual are, we will not go in more details, okay, but you will have some idea when you will do the two-lane highways. Okay, so the calculations are becoming more complex. So the manual is now incorporated into softwares. So any software which you pick in the market, which does traffic analysis, traffic simulation, they have in the background the calculations from the manual. Okay, they used to have their own software for some years, maybe up to 2000, 2006 or something. But after that, because of its adoption, they don't need to make their own software. Everybody is adopting their manual. Okay, so any software for traffic analysis and simulation has the calculations in the background from the manual. Okay, so as I said, the manual gives you definitions and methods how to do it. Okay, by the way, the manual is available online. I believe I uploaded it as well. The manual has very detailed examples, start to end, everything covered. Okay, so you can go through them. According to the manual, the capacity is defined as maximum hourly rate. Okay, we called it earlier as flow rate. So capacity, according to them, is not volume, it's not flow, it's flow rate. What do we mean by flow rate? 15 minutes converted to hour. Okay, so maximum of that value. Okay, the value which we use also in peak hour factor. Okay. The manual covers facilities which are roads and facilities which are for other type of traffic. For example, bicycle lanes, and for bus systems and train systems and so on. Okay. So obviously, when you are covering bicycle lanes or bus system or train system, you cannot say capacity number of vehicles. It will be capacity number of persons. Okay. So capacity, but again, it's a maximum flow rate of people. Capacity can be maximum flow rate of people or maximum flow rate of vehicles, depending upon what you are doing. Okay, where you are applying it. Okay. Capacity, according to the manual, is not a fixed number. It's an expectation. Okay. If I do the design like this, I'm expecting I can have 2000 vehicles on the road per hour. This is an expectation. The actual can be little bit more or less. Okay, the actual can be a little bit more or less. Okay, and this is why they came up with the concept of level of service. Okay, capacity by default is for a point. When I say capacity is this much, okay, default is it's this much on this point. Okay, now that point has some characteristics, right? Lane width, shoulder, median. If the same characteristics are observed throughout the section, then the capacity will be same throughout the section. Okay, capacity is by default for a point. Capacity is by default on a point. Capacity is this much on this point. But whatever characteristics you have on this point, if they continue same, capacity will also continue. Okay. What characteristics are we talking about? What changes capacity? According to this definition, capacity changes because of road conditions I already mentioned. Number of lanes, lane width, shoulder, median. These are all what? Road conditions. Okay. This is very obvious, right? Capacity of 2 lanes is not the same as 3 lanes. Okay. Environmental conditions, weather, lighting. Okay. This also affects capacity because it affects drivers and their speed. Okay. Weather and these things affect drivers and their speed, right? So these things will also affect the capacity. Traffic conditions. Traffic conditions mainly there are other things as well, but mainly heavy vehicles. The percentage of heavy vehicles. If you have a traffic stream which has 10% trucks, number of vehicles, let's say 2000. 10% trucks, 2000. Total is 2000. You have another traffic stream, we have the same number, 2000. But number of trucks are only 2% now. Okay, which one will be faster? 2% or 10%?
2%.
2% will be faster, right? So the capacity in those conditions will become higher. Okay, so traffic conditions mainly include the types of vehicles and control conditions. Control conditions, how you are managing traffic. Are you managing it? Do you have speed breakers, speed humps? Do you have a signal? Do you have a roundabout? Okay. Are you allowing the vehicles to cross the lane and so on? Okay. These are called as control conditions. Okay. So you know the capacity of a signal or capacity with a signal, without the signal. It's not equal, right? You have a signal and you remove the signal and put a bridge there. You change what? You change the control condition, right? It will change capacity. Okay. Capacity of the 3 uninterrupted flow facilities under ideal conditions. Okay, you will see what are the ideal conditions, but this is without any adjustment. Okay. So for multi-lane highways and freeways, the capacity depends upon its free flow speed. Okay, and the value is passenger car per hour per lane. Okay. Passenger car per hour per lane. Okay. So the ideal condition is what? All vehicles are passenger cars. Okay. Clear? And there are other ideal conditions as well. We will discuss them later on. Clear? And you can see when the speed is higher, the capacity is also higher. Okay. There are some values at which the capacity is not given because these values do not apply to this type of highway. A multi-lane highway cannot have a speed more than 75 miles per hour according to their standards. A freeway cannot have a speed less than 50 or 45. So there is no value there. 2-lane highways, the capacity is fixed because the number of lanes are always 2. So in 1 lane, 1700. 2 lanes, 3200. Is this correct? 1 lane is 1700. 2 lanes should be how much? How much should be for 2 lanes? 3200. Huh? 3400. Okay. This is why they are not same. This is the effect of 1 lane over the other. In 2-lane highways, because there is only 1 lane in one direction, that lane affects the other direction as well. Okay, so the direction which has more volume, it affects the other direction as well, even if it has gas wall. So due to that effect, both lanes cannot go up to the same value, never. One will always be lower. Okay? Clear? Sarah? I'm almost sure you are sleeping with your eyes open. Huh?
Just the last sentence, I think.
Just the last sentence. They have two lanes, okay, and each lane is for a different direction. In those cases, one lane has an effect on the other lane as well. So the higher volume, the lane which has a higher volume, affects the other lane, even if it has lower volume. So low speed in this lane will also decrease somewhat the speed in the other lane as well. So if this lane reaches 1700, the other lane will never reach the same value. Okay, so that's why you see a difference of 200 here. If both of them are 1700, it will be 3400. Okay, but only one will be 1700, the other one will be 1500. This is how you get 3200. Okay, so why doesn't it go to 1700? Because of the other lane. Not because this lane is different. Both lanes are same. If this one has a shoulder, this one also has a shoulder. This one has 12 feet, this one also has 12 feet. So even if both of them are same, but when this reaches a higher value, it will start affecting the other lane. And the other lane will automatically stop at a lower value. Alright? Okay, so this is the impact.